All right, good morning, everybody. We're going to be starting our new section, unit, and the first thing we're going to be doing is graphing. All right, today and the next class, we're going to be talking about graphing exponential functions. Then we're going to do graphing logarithmic functions. Okay, so exponentials and logs, which you have not seen before, go hand in hand together. So we're going to work on graphing today first, just exponentials. Okay. Now, an exponential function is any function that has a variable in its exponent. All right. So to the x, 1/2 to the x. All right. Now, what we first want to do is we're going to look at what the basic shape of an exponential function looks like. Okay. Now, we're going to just do y equals 2 to the x. Now, this is the only time we're doing these basic shapes right now that you're going to use like a t-chart. After we do these examples, you're not going to use a t-chart anymore. All right, but we're going to use this just to kind of get what the shape should look like. All right, so let's just plug in some values for x. If you never know what a graph looks like, you can just plug in points and see if you can figure out the shape. So let's just start with like 0. All right, so if I plug in 0, all right, plug in 0 in there, what do I get for y? 2 to the 0, anything to the 0 is 1. All right. All right, so 0, 1 is like right there. All right, what happens if I plug in 1? 2 to the first is 2. So 1, 2 is like here. Let's just do one more this way. 2 squared is 4. So 2 to the fourth is there. And let's say, what if I just did what's happening at -1? Well, 2 to the negative first. What's 2 to the negative first? 2 to the negative first is the same thing as 1 over 2 to the first, which is 1/2. So at -1, it's at 1/2. At -2, it'd be 2 to the negative second, which is 1 over 2 squared, which is 1/4. All right, which is like, say, right here. All right, so you start to see what the shape is going to look like. Now, if you think about it, if I said like -6 here, 2 to the negative 6 is 1 over 2 to the 6th. If I did -100, it'd be 1 over 2 to the 100th. It's never, ever, ever going to go below, just make the curve. It's never going to go below 0. All right. So, all right, there's the rough shape. All right, so there's the rough shape of an exponential. So if it never is going to hit 0, it's getting closer and closer and closer to 0. What is that called? Well, if you remember from when we graphed rational functions, right, that is called a asymptote. All right, so exponential functions are going to have, what kind of asymptote is that? It's a horizontal asymptote. All right, you're going to have a horizontal asymptote for exponentials, and for a basic shape, it's going to be y equals 0. All right, now things are going to get moved around. All right, it's not always going to be y equals 0, but this is the basic shape of an exponential graph. All right, so now this is something, actually, if you look at the shape of this, you guys, if anybody watches the news lately, this is an exponential function. This is kind of like how the curve looks like for coronavirus. All right, and they talk about wanting to flatten because they don't want it to go up so steep. All right, whether it's new cases or hospitalizations, whatever they're talking about. All right, you want to be able to flatten it. All right, and this is an exponential curve. All right, it gets big real fast. All right, and that's what they talk about slowing it down. But if you look at any of the websites that have data on it, this is the curve that the new cases kind of follow. All right, until it slows down. All right, so that is this. All right, now this is something that we call an exponential growth function. All right, and we'll talk about what makes a growth in a second. All right, now let's look at 1/2 to the x. All right, let's look at that one. Okay, now we'll do the same thing. If I plug in 0 for that, 1/2 to 0 is 1. If I plug in 1, 1/2 to the first is 1/2. If I plug in 2, 1/2 squared is 1/4. If I plug in -1, I actually get the reciprocal of 1/2, which is actually 2. And if I plug in -2, I get 4. So it looks like this. 0, 1 still there. 1 comma a half is here. 2 comma a fourth is like there. Negative 1, 2 is here. Negative 2, 4 is here. This is still an exponential function, all right? Has an asymptote at y equals 0. This is what we call, but it's going down. This is what we call a decay function, exponential decay. We have growth and we have decay, all right? Now, you could tell by looking at your graph, if your base of being what is being raised, so this is your base, 2 and 1/2. If this is greater than 1, it is growth. If this is less than 1, it is decay. We're talking about the absolute value of it. Don't worry about the negative. If it was negative 2, it doesn't make a difference. All right, that would still be a growth. All right, so greater than 1, if that's greater than 1, then it is a growth. If it is less than 1, it is a decay function. All right, so this is the basic shape. Now, when we graph, are only going to have to graph 2 points. All right, I'm going to want you to graph 2. And if you notice these 2 things, notice 0, 1 is in both of them. All right, that is always going to be our first point that we're going to use. All right, we're always going to use 0, 1 as a reference. All right, 0, 1. Then the second point, all right, second point here, 1 comma 2 and 1 comma 1/2. Where do you think this 2 and the 1/2 came from? Well, it came right from the base. All right, so whatever, those are the points we're going to work with all the time. 0, 1, and then 1 comma the base. All right, 0, 1, and 1 base. And we're going to end up, other things are going to happen in this graph. We're just going to move it around. All right, we're going to move them around. All right, so let's scroll down here. Oh, the other thing I want to talk about. All right, so let's talk about the domain and range of this. All right, domain are all possible x values. All right, is there any restriction on this domain? There is not. All right, so there is no restriction in the domain. So it's going to be negative infinity to infinity. And for the decay one, it's still the same thing. There is no restriction. Negative infinity to infinity. All right, the range, there's a horizontal asymptote. All right, so for both of these, what's the smallest possible y can be? It's 0, and it can't be 0, so we're going to put a parentheses around it, and it goes up to infinity. So the range for both of these is going to be from 0 to infinity. Our domain is always going to be negative infinity to infinity. The range is going to be the horizontal asymptote either to infinity or negative infinity once we have graphs down here, but we're not going to have any of those today. All right. All right, so let's scroll down and look at an example. Okay. Now, y equals 2 to the x plus 2. All right, y equals 2 to the x plus 2. So what we're going to do is there's 4 basic types of transformations that can happen, the way a graph can slide around. All right, a graph can either slide to the right and left, it can either move up or down, or it could flip vertically or flip horizontally. Okay, today we are just going to move with shifting, like slides left and right and up and down. All right, we're not going to we'll do flips next class. Okay, now y equals 2 to the x. All right, so that's our basic shape, y equals 2 to the x, which what we just graphed up there. But we have this plus 2. What is this doing to the graph? All right, so anytime you have something that is off to, we have our basic y equals our base to the x, right? Well, anything we add to the right of it or subtract to the right of it, that is going to move the graph up or down. All right, it's not attached to the x, it's off, it's not in the exponent, it's off to the right here. All right, whatever this is, since this is plus 2, what is going to happen is this is going to be a shift. We're going to shift this up 2. If this was a negative 2, we would shift this down 2. All right. So if this was a plus 8, we would shift it up 8. If it was a negative 8, we shift it down 8. Okay. So normally what would happen if this wasn't here, we would have 0, 1, right? We have a point at 0, 1, and we would have a point at 1, comma 2, right? If it was just y equals 2 to the x, that's what we would have. and we would have a horizontal asymptote there, right? Well, and our graph would look like this, all right? Well, what we're going to do is we're going to shift both of these, everything up 2. Everything's got to get moved up 2, all right? So the horizontal asymptote was at y equals 0. Now it's going to be at y equals 2. All right, so a horizontal asymptote is y equals 2. All right, for these, whatever this is here is going to end up being our horizontal asymptote. Okay, so we were at 0, 1. Now 0, 1, if I shift it up 2, now I'm at 0, 3. If I was at 1, 2, and I moved it up 2, I am now going to be at, oops, wrong, different color, but you guys get the idea. I'm now going to be at 1, 4. So I'm at 1, 4, and 0. Well, I'll put it on the side. 0, 3. All right. And then there's my asymptote. And then I go ahead and I draw my line. Doesn't cross the asymptote, and it looks like that. There is my answer. You do not need to draw in this other stuff. I'm just showing what's happening here as chef. This right here is what your final answer is. It's this guy right here. You don't have to put those points in there. I don't want this asymptote. That's my answer. All right. So you had your 2 points are at 0, 3, 1, 4. Asymptote of y equals 2. Draw the curve. That's what I'm looking for. All right. So it's just the basic shape got shifted up 2. All right. Now let's look here. Now the difference with this one is we don't have a 2 there, we have a 3. It doesn't make a difference, all right? If it's y equals 3 to the x, the only difference would be it's at 0, 1, and instead of 1, 2, it's at 1, 3. And our graph would just go up a little bit quicker, okay? Now, how is this going to affect our graph? How is the 3 to the x minus, what's this, -1? Notice the number over here was off to the right. It wasn't with the exponent. This is in the exponent. So if this moved it up or down, what do you think is going to happen here? Well, this is going to shift it left or right. And what you do is you just set this equal to 0. So what makes that equal 0? 1, positive 1. So this is going to be a shift of 1 to the right. All right, we're going to shift this 1 to the right. All right, so it's going to be a shift 1 to the right. So if we're just kind of combining these two, anything that's not connected with the exponent, this number moves up or down. When it's with the exponent, you set it equal to 0, and that's going to move it either to the right or to the left. All right, so if we're shifting to left or right, our normal asymptote is at y equals 0. That doesn't get affected, all right? It's still going to be y equals 0. Only if you shift up or down does it move, all right? And think about it. There's no number off here. Here there was a 2. That's why it's at y equals 2. Here, you're still at a horizontal asymptote. There's no number there, right? No number here. So it is y equals 0. All right, so we have a horizontal asymptote, y equals 0. All right, normally we're at 0, 1, but I'm going to shift this to the right one. All right, so that means my point is here. I was at 1, 3. I'm going to move that 1 to the right, which means I'm now at 2, 3. So I was at 0, 1. Now I'm at 1, 1. I was at 1, 3. Now I'm at 2, 3. And just got moved to the right 1. And there is our graph. All right. So by itself, off to the right, what just happened? Sorry. All right. Off to the right here. Moves it up or down, connected the exponent, moves it left or right. Okay. Next example, probably notice something. You're like, what is this? This is e to the x minus 2 plus 1. All right. E is actually a number. Okay. It's called the natural number, also referred to as Euler's number. All right. Invented by Euler. All right. We'll use it a lot. We talk about natural logs when we talk about logarithms. All right. But E is roughly, that's supposed to be roughly 2.718. That's the value of E. All right. goes on more than that. But E is it's a number. It is not a variable. All right. So we're going to treat this just like we would, 2 to the x, 3 to the x. All right. So we're not going to write it as 2.718. We're going to write it as E. And if we add something to it, we could write E plus 1 and so on. And you'll see in the examples. All right. But if I was just to graph y equals e to the x, all right, it would still have a horizontal asymptote at 0, just like everything else. We would be 0, 1, and then it's 1 comma the base. But what's the base? 2.718 is E. So that's roughly, somewhere in between here. This is 1 comma E, and the graph would look identical. Okay. Now we don't need to, let me just get that away. All right. So that's the first thing. That's what E is. So you don't get freaked out by E. E is just a normal number. All right. It just has a value of 2.718. Now, there's two things that you should recognize here. We have a -2 in the exponent, x minus 2, and we have a plus 1 here. So we actually have two shifts going on. This is getting shifted up 1. And then if I set this equal to 0, this is getting shifted to the right 2. So we have two shifts going on here. Okay. So put a couple things on here. Oh, jeez. Okay. So what happens is normally I'm at 0 for my horizontal asymptote. This new thing is going to be my horizontal asymptote, which is 1. So it was at 0, it got shifted up 1. So that's my horizontal asymptote. Okay. Now, for normally I'm at 0, 1. Okay. Normally I'm at 0, 1. And I have two things going on here. All right. So I'm normally here. Let me just switch color, trying to keep it so you can see. I'm normally here, right? 0, 1. I am going to move to the right 2 and then up 1. So instead of being at 0, 1, I'm now at 2, 1, right? I was at 0, 1. I shifted 2 to the right and up 1. Normally, I'm at 1 comma E. So instead, I'm going to move to the right 2. So instead of being at 1, I'm going to be at 3. And instead of being at E, I'm going to be at E plus 1, or 3.718. But you just have to label it as 3 comma E. And then you draw your graph, and it looks something like that. There you go. Now, all right. Now, I forgot to do these for the first two examples, but it's all the same. Domain and range. Okay. Domain, always -infinity to infinity. There's no restriction on the x's. Range, it's going to be whatever horizontal asymptote. In this case, it's going up to infinity. So it's going to be 1 to infinity. If it was the graph was below, which we were not going to have until we have a flip, then it'd be -infinity to 1. But here's just 1 to infinity. Okay. All right. All right, last one. Oh, looks like I forgot to put a XY plane on there. Okay. So what I want you to know is a couple things when you look at this. First is that you have 1/2 here. So this should be a less than 1. So this should be a exponential decay. So should be going down in that direction. Okay. It should be going down in that direction. The other thing, what kind of shifts do I have? What kind of transformations do I have going on to this graph? All right. Well, I have this and I have that. This is going to move it -2. It's going to move it down 2. This is going to move it to the what 3? It's going to move it to the left 3, because if I set this equal to 0, I would get a -3. So what is my horizontal asymptote going to be for this problem? Well, my horizontal asymptote is whatever that number is. So it's going to be -2. So I'm going to -2. All right. All right. So normally I'm at 0, 1, right? 0, 1. But I have two things going on here. I have to move it to the left 3. So I'm normally here, move it to the left 3, and then down 2. Why do I move it to the left 3? So it's at 0, 1. So now I'm not at 0, I'm at -3. and I was at 1 for my y coordinate. Now I moved down 2. I'm at -1. So this point is -3, -1. All right. Then, should probably put it on the other side. Sorry. Should have put it over here. So my graph should go down this way. Then I'm at 1 comma a half. All right. Well, instead of being at 1, and then actually one thing it's a little bit, if I was at 1 comma half, all right, that means if I move to the left 3, it'd be at -2. And if I was at 1/2 -2, it should be -1/2, which is right here. So my graph would look like this. Okay. It might be better. So instead of doing for this kind that are decay when it's less than 1 like this, instead of doing 1 comma the base, if you did -1 at -1, what would this point be? It'd be at 2. It might be easier to shift -1, 2, so not dealing with the fraction, which would be to the left 3, which would be like -4, and at -3 we down 1. So it'd be like right here, which it does. It works out perfectly. So if you wanted that point in there, if you wanted to put in -4, +1, there as well. And there's our 2 points. That's all you need. All right. If you have these 2 points, great. If you have these 2 points, still good. All right. As long as you have 2 points, you're good to go. Okay. So the domain of this would be -∞ to infinity. Range would be, where's my asymptote? -2 to infinity. Okay. So what is important to make sure you recognize is that we talked about 2 types of ways to shift it. It's either left and right, and that comes from anything with the exponent, and up and down when it's off by number by itself, not with the x. All right. What we're going to talk about next class is flips, like horizontal and vertical flips. And that's going to come with negatives out in front or with x, but we'll talk about that next class. All right. So you have a homework assignment. There's only 4 problems. All of them just involve shifts left, right, and up and down. All right. So hopefully you guys will be able to understand those. If not, I'll, reach out and ask any questions that you have. And then hopefully whatever you don't understand today, when we go over the stuff again in the next class, maybe it'll start to sink in a little bit more. Okay. I hope you guys are doing well, and I'll talk to you soon.